All right, let's get started on the glorious adventure of ray tracing. Ray tracing is all about figuring out where rays from some object come back together after hitting a mirror or going through a lens. Sometimes they don't go together, and then we have to ask, where do they appear to be coming from? The first thing that you've got to do is get some graph paper, draw an axis like this, and usually you'll be given the focal length or the radius of curvature, and from that you have to figure out what your scale is going to be for your horizontal axis. You choose a scale for the vertical axis sometimes as well. It does not have to be the same scale. Alright, I'm going to do a succession of these, and I'm going to start with the convex mirror. And I'm going to put the object outside the focal point. I'm going to put it just about at the left end of the page. And this is how I draw an object. I'm going to make it dark. That's why I have the Sharpie. And I'm going to label it with OBJ for object. Now, that object could be anything. It doesn't have to be arrow-shaped. We use the arrow so that the bottom end of it is going to be along the axis. So any rays coming from it, if they recombine, are going to recombine on the axis. It's the tip that's important. So we don't have to consider all the rest of the shape of this, just the tip. And we are going to look for 3 distinct rays. And if we can find those 3 distinct rays, then all 3 of them will either recombine in a point or diverge from some point. So let's get at it. If I have a convex mirror like this, that means that the entire right-hand side here is not going to see any light. So I like to do this, a bit of shading on the dark side of that mirror. And let's look at this. If this is an actual spherical surface, and if I've drawn it to scale, that means that any ray going through this radius, the far radius, is going to be perpendicular to that surface, no matter which way I draw it. And that means that the normal is going to be where the incoming ray comes in. So here's what I do. I've got written in black here the shape of the actual mirror. I've drawn in red here a plane at the point where this mirror hits the axis. And I'm going to use the plane and pretend as if all the bending takes place at that plane. So if I have an incoming ray that's headed towards that far radius, it's not going to get past this red line. So I'll draw a dashed line here to show that that's where it was headed, but it's going to reflect right off that normal, and so that means that the incoming ray comes back on itself. So for number 1, I have an incoming through, put that in quotes because it never gets there, through the far radius, reflects on itself. That's number 1. Now I said there were going to be 3, so let's get to the next ones. The next one, well actually both of these next ones have 2 things in common. One is a parallel beam, parallel to this axis, and the other is a focal point. So let's start with one that goes in parallel. And again, we're going to bend it at the red line, not at the surface of the mirror, because that's our model, and the math works out if we do that. So this is a parallel incoming. And I said it has to be linked somehow to a focal point. When it gets to this mirror, notice the normal is going to point like this, so it will reflect away from the axis. So that means the only focal point that comes into play is this one right here. So I'm going to draw this one as if it were coming from the focal point like this. And it's going to diverge away like that. Notice that 1 and 2 never meet, but they do appear as if they're diverging from some point over in here, and that point is where our image is going to be. So I'm going to cheat a little bit. If that's where the image is, then the outgoing parallel beam is going to be about this height. So that means I have a beam that's going to be hitting right about at that point. And that's the beam that's aiming for the far focal point, like that. And I draw that dashed line because the rays never get there. And so it's going to come out this way. It goes in like this. This is number 3. It goes out like that, number 3. The parallel incoming reflects as if coming from the far focal point. Number 3 was incoming toward the far focal point. It will be outgoing as a parallel ray. And by parallel, I mean parallel to this axis right here. Now, let's look at where that beam appears to be coming from. It appears as if it had come from the other mirror and had come out straight parallel to that axis. So as if it came from, bingo, this point right here, where all the other 2 of these rays came from, or appeared to come from. So that means that we have an image right here. It's on the dark side of the mirror, so it never really forms. But I'm going to write here image. In fact, let's get out the Sharpie and make it official. There it is. There's my image. So it's inside the far focal point right here. Now, let's talk about how I can characterize this image. First of all, is it real or virtual? These rays never actually cross. It's virtual. Is it upright or inverted? I don't think any comments necessary there. Is it enlarged or reduced? I just look at how high it is vertically, and I see it's a lot smaller. And so that is how we do our first ray tracing.